I'm in SPSS and I'm going to have a look at doing some graphs with the how long till you blink dataset. So this was a project done by some students a few years ago where they were interested in how long people could go without blinking depending on whether they were inside a building or outside a building in the sunlight. They were expecting that they would find that people could hold their eyes open for longer when they were inside. They also collected some other variables on the participants, such as their age, I think how many hours sleep they had, and if they had any eye cover or not. So we'll have a look at that now. I'm just using the open data function in SPSS, and I've told it to look for Excel files, and I've picked the how long do you blink. So I'll open that up, and I would like to read the variable names from the first row of data. Okay, it's just popped it onto my other monitor. And I'll just get the output document over there too. So the first thing I want to do is just check that it's imported my data correctly. If I go to the data view, I can see I've got my time, age, sleep, eye cover, gender and area. My variable names are in the header row, and I've got all my data running down with one observation per row. So that's correct. It doesn't seem to have made any mistakes and put any data in the wrong column. If I scroll right down, I can see that I've got 114 observations. So that means the students were able to get 114 people willing to participate in their experiment. I might, because SPSS takes out the brackets for the name and then it sticks it in the label. The label is what it will put on the graphs. So really I can go into here, just double click and take out the seconds. You can't have any spaces in your names for SPSS, so you've got to make sure you take it won't let you have any spaces, and if you want to put a nicer looking label in it, you can put that over here. The other thing you might want to do is put some values in for your nominal variables. So for gender, I know that it's male and female. I can't remember what they've called all the eye cover off the top of my head, so I'll just go into values. And if we click on this blue bit, we can add a separate value in for each one that appears in the data set. So if they had coded this as just M for male, we could then say we'll give that a label male on all the graphs that you do. As it is, I think they actually wrote in the whole word anyway. Just click add female. Call that female. I'll just have to go back and check that that's what they called their data. Okay, let's go into the data view. Yep, male and female, and then they've got in and out. So these are the values that are possible. So it means in your data you can code these if you want to as 1 and 0 or 1 and 2. You can just give them a number. You still have to tell SPSS that it's a string variable and it's nominal, and give it some values. So if we go in and look at some graphs for this data, we might be interested in doing a couple of simple charts for these nominal variables, just because we didn't do the experiment, so we don't actually know how many people. Well, we can see that they did 114 people, but we don't actually know the split of gender or how many they tested inside or how many they tested outside. So it's a good idea to have a little poke around. If we go into Chart Builder, now if we're looking at plotting categorical variables where we just want to count up the number that fall into each category, we either want a pie chart or a bar chart. We can try a pie chart first, and let's just try plotting the area. So this is whether the people tried to keep their eyes open when they were inside or outside. And we've got this preview of the chart here, but this is just something that SPSS makes up. It's not accurate. It doesn't reflect the data. Okay, now in our output window we've got the code that you would use if you were doing this programmatically. We're just going to use the menu options. You can actually save this if you want to, but we won't need to do that. You can write little programs for SPSS to do something for you rather than using the menu options. Here we can see that they had nearly the same number of people inside versus outside. Now we might want SPSS to go through and count all of these things and actually give us the numbers inside and outside, and that would be under Descriptive Statistics, and we'll do that in a different video. Just now I'm going to just look at graphs. So that's the area. We might be interested in this eye cover one, and that's whether or not the participants had anything covering their eyes, such as glasses or lenses. Let's try that with a bar chart. And we've got a few different options here. We just want the simplest one. So I'll drag that on. It keeps what you had before, so I could just do area again as a bar chart, but I don't want to. I want to do eye cover this time. So let me drag that on, and it will take out the area and put in the eye cover. And then it says up the side it's going to count. So it'll count the number of people in each category. So we can see that most of the people, I'm looking across, that's about 100 of them, had no eye cover, and we had about 10 people with glasses and a few people with lenses. I can't see exactly how many there are, but we could get a table out of how many in each group if we wanted it. Graphs are a nice way of summarizing information so that you can see what's going on quite quickly. Now, so that's how we would plot a categorical variable. We might be interested now in plotting some of our continuous or count variables. Age is technically a count variable. We can treat it as continuous. And the sleep is people just counting the number of hours they think they slept like the night before. So technically that's a count variable too, but with large counts we can usually just treat them as continuous. And then time presumably was measured on a stopwatch. So if we go into Chart Builder, let's try a dot plot. Not sure, I think that's a scatter plot. I think it's this one we want for a simple dot plot. Yep, it's just popped up the little info chart, simple dot plot. So let's drag that on. Now we don't want to do eye cover, let's try sleep. It's not going to let me take it out, so let's just put sleep on top of it. Sleep in hours. Now we have the option over here of being asymmetric, symmetric or flat. I usually wouldn't recommend flat just because it'll put dots on top. If you had, say, two people that both said they slept 8 hours, which is highly likely, they may just cover each other and then you can't see that that's lots of observations. Asymmetric and symmetric, it depends whether or not you want to compare two different sleep charts. If you wanted to do a dot plot just for females and then compare that with the males, you might want them all flat at the bottom, so you might want them asymmetric. So let's try that one. And so now we can see that, gosh, a lot of people only got 6 hours sleep. There we go. And a couple of people had 0 hours sleep. That's not a good sign. And a whopping, what's that, 11 hours? Will it tell us if we click onto it? No. So somebody had a lot of sleep. So each dot in this case represents one observation or one person. You can double click into this and modify what all these things look like if you want to. You might maybe want to give them a colour or something. Apply. It's a bit angry red. Alright. So you can customize these if you want to. Alright, let's try a different graph. Often we'll do a histogram of continuous variables to see if they look roughly bell-shaped and symmetrical, and we might be looking at how far the tails extend out. That's each end of the distribution. So let's go to histogram. We'll just pick a simple one. And I don't want to do sleep. Let's look at time. And this is the time that people were able to go without blinking. Again, we get a little preview, but this isn't necessarily what our data looks like. It's just the example that SPSS gives us. So this is showing us that most people were falling in this area here, sort of 25 seconds and less. So not holding their eyes open for a massively long amount of time. I haven't tried doing this myself. I don't know how long I can go without blinking. It'd be interesting to try that. But there are a few people out here which really held their eyes open for an awfully long time. Because this data it's not quite bell-shaped, it's sort of stopped at 0 because obviously the numbers have to be positive, but it's really been pulled out on the right-hand side in the positive direction, and so this would be called positively skewed or right skewed. It gives us a little bit of information up the side here. N equals 114 is the sample size, so 114 participants with a mean of 21 or so seconds to hold their eyes open. The last thing I'll have a look at are some box plots. So this is how long people could hold their eyes open for all together, but really we're probably more interested in differences between groups. So we might be interested in the differences between the people who were inside and the ones who were outside, just to see if the ones who were inside could hold their eyes open a bit longer. So we're going to have a look at a box plot now. And the reason that box plots are nice for comparing groups is that the box plot shows us where the middle of the data set is, so we can see if there's any difference in the middles, and then also it marks the extreme observations for us. So the time is going to go on the y-axis, so it's plotting from low to high, how long they could keep their eyes open, and then across it's going to split it into different groups. And I've got area here, so again it's just given me a demo chart. I don't actually have 3 categories, I've only got 2, just inside and outside. Okay, so now we can see that so the people who are going without blinking inside, their observations sort of look roughly symmetrical actually. This is the median here, which is the middle observation of the data set, except that we've got all these outliers, all these extreme variable values. So if we took if we could get all our people together that we tested and line them up in order of time they could hold their eyes open from 0 to 130, the person that was standing in the middle would be on this line here. So it's not the mean or the average, it's actually the middle observation, it's the middle of the data set. It's not possible to tell from these graphs, on this graph in this instance, if there's a sort of a significant difference between these two. There's quite a lot of overlap. We'd have to actually do a test for that. But it's always interesting to show what the data looks like. Now we can actually take this a little bit further. We can have a look at within each of these groups, the inside and the outside. Is there then a difference between, say, the males and the females? And we can put that into a box plot as well, but this time you can see here we've got the blues and the greens, so there's groups within groups. So we've got area as one group and it's kept the time as second, so let's try and drop gender in there as well. So I'm going to drop 2 in. So I've just dropped gender over the colour. So the category on the x-axis will be the area, and then the box plots will be coloured by gender, and we could do that the opposite way around as well, depending on what we were interested in. So here we've got the area again, inside and outside, and then we've got, it says up here, the females in blue and the males in green. And you can't see a whole lot of difference here. So we would look at a plot like this if we were interested in the differences in the genders once we knew we were outside or inside. We might also be interested in looking at that the other way round, that is if splitting into all the females together first and then looking at inside and outside just for the females. So in that case we would have to switch around where we put our labels on the chart. take that out and take that out. And let's put gender in for the x-axis, so it'll split us into females and males. And our colours we're going to do by area. So these are the same variables, but we're just going to plot them the other way around. And the one that you choose depends on the comparison that you're interested in. So within the females, we can see if there was a difference between the females who were inside and the ones who were outside. And it actually does look like they were a little bit, they could hold their eyes open for a little bit less outside. They're a little bit lower. I'm not sure if there's really any difference there. Whether or not this is just due to random variation or if it's statistically significant, I don't know. We would have to run a test for that. If there is a difference, it would be very small. There's nothing massively different between these two groups that I can see on this chart. So I encourage you to go through and play with some of these graphs and also double click into these and see if you can change some of the options.